Hello, everyone. It's my great honor and pleasure that I'm here today to participate in this prestigious conference with different outstanding researchers and scientists from different regions all over the world. I hope that we can contribute with each other and exchange our ideas about different research projects that we are dealing with. My name is Ahmed Khaled, and I'm from the School of Earth Science and Resources at Chai University in China, doing my PhD under the Chinese government scholarship and focusing in petroleum geology. Focusing in petroleum geology, and my study direction is the Precambrian source rocks. The Precambrian source rocks is a hot topic recently, as it proved to have commercial oil and gas accumulations, when it was previously believed that the commercial oil and gas accumulations just exist in the Photomorphographs. My topic is the Paleoenvironmental conditions, and it's controlling on the organic matter enrichment of the late Paleoproterozoic with transformation dark shells in the Yuncheng Basin, North China. I'm going to cover some points in my talk, starting by introducing the study area and moving to research methodologies, and also introducing the results and discuss these results of some Paleoenvironmental conditions. Finally, I'm going to introduce the accumulation model of the organic matter enrichment and the Cuizhuang formation. Cuizhuang formation source rock is located in the Yuncheng Basin, which is one of the basins within the Shanxi Rift system. The Yuncheng Basin has been propagated during the early Miocene, and the whole rift system propagated during the Cenozoic. The Yuncheng Basin is located also to the southeastern of the Redux Basin, which is the second largest sedimentary basin in China. We studied the Cuizhuang formation for Cuizhuang well, which is the only survey well that penetrated the whole thickness of the Cuizhuang formation, which consists of shells and a small amount of sandstones. The shells are of three types, which are red, gray, and dark shells from the top to the bottom, and the whole thickness of the Cuizhuang formation is 100 meters in thickness. However, we used some methodologies for analysis of organic and inorganic chemistry. The organic chemistry, we use the total organic carbon and bitumen reflectance, and also material compositions. Inorganic chemistry, we use the mineralogy, major trace and elements. So now let's move to the results. So starting by the organic geochemistry. The organic geochemistry of the Cuizhuang formation by the total organic carbon TOC, we can say it ranges from 0.13 to 1.09 with an average of 0.51. This indicate that the Cuizhuang formation is a fair source rock, and also has a capability of generating hydrocarbons. Thermal maturity is relatively high and reached a dry gas generation window with an average of 2.24. This indicated that the Cuizhuang formation has already generated crude oil and also reached the dry gas generation window. The material compositions of the Cuizhuang formation is abundant by suborbials, and there is small amount of phytonate-like and more or less of inertinites. So under the microscope and using some photomorphographs, we can say that the suborbials are the widely distributed, the abundant minerals in the Yuncheng Formation source rocks. However, the upper two figures are using reflected white light, and the upper and the lower are using transmitted white light. Moving to the inorganic chemistry. However, starting by the mineral compositions, we can say that the Yuncheng Formation source rock is abundant by clay and quartz, with an average of the total of these two minerals about 80%. And using the ternary diagram proposed by Gamero Diaz, we can say that the Yuncheng Formation is mainly located within the clay-rich siliceous mudstone, and also the argillaceous siliceous mudstone. The cores show that the Yuncheng Formation is a blocky in texture, and under the microscope, the mineral composition the mineral compositions are widely distributed by clay and quartz cement. The quartz cement formed during the transformation of the clay minerals. So, major trace and rare earth elements. The major and trace elements, and comparing with the upper continental crust values, we can see that some minerals are enriched, some are near to the UCC values, some are depleted. And for the rare earth elements, we can say that for the light rare earth elements, the trend is inclined from the left to the right, and for the heavier earth elements, the trend is almost plain. However, this can give us an idea that the materials were stable during the deposition and also were identical. Now we need to discuss these results for some paleoenvironmental conditions. However, deposition site. From the deposition site, we can say that by using some major elements, proxies, that the Yuncheng Formation source rock deposited on a passive continental meridian. The passive continental meridian is suitable for the Yuncheng Formation source rock when during the Columbia supercontinent, when the Yuncheng Formation deposited during that time, the passive continental meridian was suitable for the plastic rocks sedimentations. Paleoclimate. So paleoclimate is very important, and it's affected by different geologic processes. However, we use two proxies. The most important one is the chemical alteration index. However, the chemical alteration index can estimate the weathering intensity and also the paleoclimate. The results show that the paleoclimate was moderate, warm, and humid climatic conditions. And in correlation with the enrichment of the organic matter, there is no any poised correlation that can give us an idea that it enriched the organic matter in the Yuncheng Formation source rock. There is no correlation with TOC, so there is no effect to enrich the organic matter enrichment. However, another proxy, which is SR over BA, this ratio can indicate the salinity of the seawater and also the climate condition. Most of the values are less than 0.5. This indicates low salinity and humid climate conditions, which is consistent with the chemical alteration index values. The value productivity is the most important factor that can enrich the organic matter accumulation of the source rocks. However, we use some nutrient elements values, which is can enrich the value productivity or cannot if it's the values is very low. However, in comparison with the UCC values, the most or all of the nutrient elements and some ratios here show very low content, which indicate that the value productivity was low during the deposition of the structure formation source rock, and the played maybe a negative way to enrich the organic matter enrichment of the structure formation source rock. So we used some correlations with TOC, and we can indicate that there is a negative correlation with TOC, and this gives us an idea that the productivity was low during the deposition of the structure formation source rock and led to the low TOC content. Also, the hydrothermal activities show there is no any upwise correlation with TOC, which indicate that the hydrothermal activities contribute negatively to enrich the organic matter accumulations. Redox conditions is the second important factor that can enrich the organic matter accumulation. However, the redox conditions show that the structure formation deposited under an anoxic redox conditions. We used the element vanadium, which is very suitable to trace the redox conditions, as it cannot be easily mobilized, then it can preserve original informations. However, we can say also that the dark shells have been more enriched under the anoxic conditions more than the red and the gray shells. So, how is the contribution to the organic matter enrichment for the redox conditions? So, as we say, the redox conditions were anoxic redox conditions, and it showed the very strong positive correlations with TOC. This indicated that the TOC or the anoxic redox environment contributed to the enrichment of the organic matter enrichment of the structure formation dark shells. Dilation conditions, including the deuterial inputs and sedimentation rates. So we used some proxies of deuterial inputs, and it shows that there is no any opposed correlation with TOC, and indicated that the deuterial inputs has no any effect on the enrichment of the organic matter, but the sedimentary rates of both gray, red, and dark shells show that the dark shells deposited in a faster rate than the red and the gray. This was indicated by using some rare earth elements, which can give us an idea about the sedimentary rate of the shells here. So the dark shells sedimented in a faster rate than the red and the gray shells. This gives an idea that anoxic redox conditions and faster sedimentation rate than the gray and red shells has been contributed to the enrichment of the organic matter accumulation of the Switchern Formation directions. And how about the water depth? So using the ratio of zirconium and rubidium can give us an idea about the water depth. So the values of this ratio decreases with the increasing water depth and increasing with the decreasing of the water depth. However, the dark shells show that it was deposited in deeper water depth than the red and the gray shells. However, now we can estimate the accumulation model of the Switchern Formation source rock. As we see here, anoxic redox conditions, faster sedimentation rate contributed to the enrichment of the organic matter of the dark shell, the low productivity taking place here, and moderate warm and humid climate with low salinity of seawater, low nutrient contents also contributed to the low productivity of the Switchern Formation dark shells. And this is the whole accumulation model of the Switchern Formation dark shell in the Switchern Formation source rock in the Yuncheng Basin. However, the conclusions is as presented here, and it shows that argillaceous quartz and clay minerals are dominant in Switchern Formation source rock, and the Switchern Formation source rock is an effective source rock with fair source rock, type 1 organic matter and high thermal maturity. The deposition was in a passive continental margin under anoxic sedimentary environment. Climate was moderate, warm and humid conditions. Salinity was low. The paleoproductivity was low, then led to the relatively low TOC content. Anoxic redox environment and higher sedimentation rate than the gray and red shells contributed to the enrichment of the organic matter. Finally, this is my talk, and I'm really happy to participate in this estimated conference, and I hope that I can also have the chance to participate in the upcoming events in this conference, and I hope that I can see you also in the other editions of this conference. Thank you so much, and wish you all the best.